All right, so this is kind of a wordy problem. So go ahead and take some time to solve it and pause now. All right, so the problem, this problem, I think once you draw the diagram and once you figure out what's going on is fairly straightforward. So again, I like to draw these types of things and I feel like I have to draw it to be able to understand it. So we've got a fire truck with its siren on and it's moving away at a constant velocity of 17 meters per second. So I'm going to draw the fire truck just as a siren. And we're going to say it's moving to the right at 17 meters per second, right? And so there are people inside of a car. And I'm going to draw the car as just a box. And so, of course, when the fire truck is moving away from them at 17 meters per second, they're going to hear a lower frequency, right? The Doppler effect, of course, we always think of it conceptually as the wave is physically getting stretched, right? And again, sound does not actually look like that, but for this sake, we can understand that, right? The wave is getting stretched, and so the sound is going to be, the frequency we're going to hear is lower than what's actually coming out of the siren, right? But now it says that we decide to chase after the fire truck. I don't know why we decided to do that, but let's just say we did. We decided to chase after the fire truck at a velocity of 12 meters per second. All right, so what's happening here? Let's think about this, right? We're moving at 12 meters per second. We're chasing the fire truck, but the fire truck is still moving faster than us, right? The fire truck is still moving at 17 meters per second. So we can think of it in terms of relative velocity, that the fire truck is moving at 5 meters per second this way, right? Or that the distance between us is growing, we could say also, at 5 meters per second relative to the car, right? And so again, this is relative velocity, right? We're moving 12, the truck's moving 17, and so relatively, the truck is moving 5 meters per second away from us. And so what does that mean for our frequency? I want you to think conceptually in terms of what that means. And I guess we'll go through the answer choices and think about them conceptually. So A says that the perceived frequency is the same because the fire truck is still moving away, so the sound waves continue to stretch in the same way. So this part of the answer choice is correct because the fire truck, the part to the right of this, I should say, because the fire truck is still moving away, that's true. The sound waves continue to stretch in the same way, that's true. But the frequency is not going to be the same. The perceived frequency is going to change, right? Here, when the velocity was 17, the waves were getting stretched a lot, right? They're getting stretched a lot, we could say. Now, when we're moving, when the distance between us, the relative velocity is just 5, they're not going to be as stretched. So we can kind of do it like that. So the perceived frequency is not going to be the same. The perceived frequency, B says the perceived frequency drops even lower than before because the fire truck is further away from the observer. Well, it's not about how far away the truck is away from us. It's about how fast it's moving relative to us, right? Maybe we don't hear it as loudly, but the frequency shouldn't be affected by the distance. Again, it's just affected by the relative velocity. And in this case, the perceived frequency is not going to drop even lower, right? Because the velocity between us has actually decreased. And so the perceived frequency should actually go higher than it was before, right? So C says the perceived frequency rises above its true value as if the fire truck were now moving toward the observer instead of away. So this is not correct either because it's still not above its true value. We're still getting a distortion because the fire truck is still moving away from us. So the frequency is still going to be lower than the actual frequency, right? So this is not correct. And finally, D, of course, is the correct answer by process of elimination. The perceived frequency rises, meaning the sound is still lower than its true value, right? And that's what we said because the truck is still moving away from us. But the pitch is higher than it would have been if the observer had remained stationary. And that makes sense, right? The frequency that we hear, the perceived frequency, is still higher than it was. It's higher than it was before, right? But it's higher than it would have been than it was when we were stationary, right? So the perceived frequency has gone higher, but it's still lower than the true value, than the value that, the frequency of the sound coming out of the siren. So the correct answer here is D. Again, a bit of a tough problem, but thinking about the Doppler effect in terms of relative velocity is a great way to get a conceptual and intuitive understanding of this. And that's all really you really need to know for the MCAT is have that conceptual understanding of what's going on, right? So the correct answer here is going to be D.